Welcome back to part 2 of architectural consideration of smart objects. So in the previous lecture we were seeing about what is smart object and what are the different kind of communication patterns you have, the device to device, device to cloud, device to gateway and the backend model. And now this material or this lecture would help you understand more about the justification of reuse. So how we should think of the deployment model of smart objects and how do you adapt to the change if at all something is there, the security and the privacy aspects with respect to smart objects. Slide tries to justify the importance of reuse of internet of protocols than developing new ones. So which is better? So is the reuse of the available standards better or designing something new, redesigning or extending by more modification, which is better? So which is the better one? So that is the question to be answered from this slide. So now if you look at RFC 1958, which is about the internet, so it is like the greatest lessons learned from earlier days. So that's what we call it as experience. Based on the experience, not only for the life, it is also for these business models and technology. Things are learned from history. So what the way the or how the way the internet got into is the internet and its architecture have grown in evolutionary fashion from the modest beginnings. Okay, it started very small rather than from a grand plan. And the good analogy to justify that reuse is better is that if you are the development of the internet is that of constantly renewing the individual streets of or and buildings of a city rather than raising the whole city out and then rebuilding it, which is not at all a good solution. So with whatever you have, you may have to reuse and then grow up on whatever you already have. So that is the justification which is given. Having said all of this, but then even after saying all this, people are still developing their own new proprietary models and industry stuffs to maybe show that theirs is better or things like that, but it's not going to do a bigger good. So what people are trying to say is if you already have something which is up and working, why do you really wanted to go and try to develop something from the scratch? So that is the whole idea about it. But still people are trying to have these new proprietary and industry models, specific protocol mechanisms or architecture models, which is adding problem than more to solve. And in addition to the architectural concerns, developing the new protocols and mechanisms is generally more risky. So apart from architectural changes, people are also going in for new protocols, new mechanisms, which is more expensive and risky than using your existing standards, than reusing existing standards. So why? Because it is going to cost you more in case of design, implementation, testing, and a lot of other things. And the secondary cost is also going to get more because whenever you design something new, then you have to train your staff to become expertise on that skill set and things like that. And then because of people coming in with lots of new models, so it has brought out some points of concern which are listed here, which is the vertical profiling. So what does that say is people are trying to come up with some kind of and develop domain specific profiles whereby they select minimum subset of protocols, not all. So they choose, every company is going to choose some protocols which are very mandatory, so needed for the specific operating environment. So depending on the domain, so they choose very minimal set of protocols. So now by doing this, so people are going to give some, at least the at the building block level, there will be some commonality, because each one of the trying to give up their minimal set of requirements. So this, on a longer run, they think this may get us to some point of commonality and generic, which is again may be very good in terms of reuse. So because already people have gone a long way and designed something new on their own, and now the interoperability is going to become an issue, and nobody is ready to accept that their model is not better than the other one. So now somewhere um, a parallel have to be drawn, and then things have to be moved on one side. So people are working out on this vertical profiles to bring out some commonality ground. And then again, this industry specific solution is again, every industry wanted to have their own models and things like that. So the recommendation what the community developers or the standardization units are trying to give them is, just don't take one module. Like for example, if you look at internet protocol suite, is much more it has within itself than the mere IP. Internet protocol, which we say, is just one part of the IP suite. So they're saying whenever you observe something, please observe them in whole, so that you don't end up in interoperability issues and things like that. Mm. And then the next problem which comes up is the tight coupling, where if you look at many applications are built around specific set of very specific set of servers, devices, and things like that. But now if you look little deeper, most of the services can be reused, but people don't think on that angle. So people are trying to say, if though you have specific set of servers and devices, please look into it. If there is something can be shared across, then you can lose your coupling and then don't have it tight. Okay, that is what the slide says, which again tries to emphasize or justify that reuse is better than developing something from scratch, which is the theme or the motto of smart objects. All this time we were discussing about the importance or the substantiation for reuse of existing protocol, which is the theme for the smart objects. But everything comes with if and but. So what happens here is, so though there is proper substantiation given, there are some challenges on reusing the existing models. Though we say the internet protocol is mostly adopted, and it is very good if you adopt it for the smart object, but then the challenge is there are a lot of variants or improvements on the internet protocol itself on the way. So now if somebody have developed on one particular extension um, and adopted it, okay, and then after some time it is the model on which they started working with, or the model which they adopted, somebody starts disproving it, or some challenge comes in that. So the whole model which was developed by reusing that now comes into a challenging point. So now picking up, so though you have the recommendation of wholesome adoptability, there are some places at which picking the specific protocols for a particular use case becomes very tricky. So as the internet is also evolving, certain protocols and protocol extensions have become the norm, no doubt. But others have become difficult to use in all circumstances. In some circumstances, yes, they do good, but at some places they suffer very badly. So one example can be given with respect to IP options enabled packets. So in 2005, this was founded in a study. So what happened was, whenever a router chooses to drop a packet, so which packet is mostly chosen to drop? It was found that the packets which had these IP options were being dropped out more than 50 percentage. So in those cases, if anybody have adopted for their smart object this IP enabled options model, then they may have to work out on this, because this was not maybe really thought of when somebody is adopting it. They might have been happy with IP option enabled packets and they might have gone about with that. But now how a router behaves on this, maybe it might be creating some issue if this model is adopted for the smart objects. And there are a lot of examples like this which you can refer in the link given. This slide explains about how do you design yourself, how the developers design expecting the changes. So it's a design for change. So now how to embrace rapid innovation and at the same time accomplish a high level of interoperability is $1 million question if you want to compete in the marketplace. So RFC 1263 points out that, which states protocol change happens and is currently happening at a very respectable clip. We simply propose for the technology developing engineers to explicitly deal with the changes rather than to hold back the flood, which is not going to help them. So you have to flow along the flood and then do things accordingly. But in order to accomplish this, some researchers have suggested that there are two simple ways by which you can achieve this. The first one is break your complex systems into modular parts, smaller ones, so that one does not spill over and distort unrelated issues. If something goes wrong, if you do it in small chunks, so you can just throw out that and then work out things instead of taking out the full model, and then once something goes wrong, the whole chain gets affected. So instead of that, just chunk it into smaller modules and then work out. So that was one point. Second point is designed for choice to permit the different players to express their preferences. Choice often requires open interfaces, yes, so there is a little of work towards this. But these two models, if followed, then adopting or adapting for the change becomes easier. But the main challenge with the above approach is predicting how conflicts among the different players will evolve. So nobody knows, like, only when the conflict happens we know how, okay, it has happened. But how complex conflicts can happen among different players, mm, it's it's very tough to predict in prior. So this may have to be tackled. But luckily, the design of the systems does not need to be cast in stone. It's not that rigid during the design phase. So it may adjust dynamically later, since many of the protocols allow for configurability and the dynamic discovery. So it's very much possible that you change something and you're allowed to change something. Though you made that in a design phase, you're allowed to dynamically change as need demands. So this is the slide which explains on the security considerations of smart objects. The security is often more very complex in case of to deploy in case of smart objects compared to traditional computing system, because of the constraints they have. Point number one. And point number two is they are someone who are directly in contact with physical world, be it camera or be it a device in the house. So it is potentially dangerous if that gets hacked, because it is directly communicating to the humans or the environment in which he or she lives. And the second thing is, as I told you, it is the devices are very constrained. So giving that level of security with the constrained resources which you have is very challenging. So there are some key considerations critical for the design of security which is listed here. The first one is, how would you establish the trust for a smart object? So the authentication, the credentials, how are we going to deal about that? And the second is, there are these are the smart objects which are going to be deployed in places where the additional physical security may not be possible, or it is very difficult to give it. because you're going to put it in an open space, because it needs to be in the open space. Maybe you are going to measure the air quality and things like that, and forest fire. So how are we going to deal about that? So somebody may take it and go off. So how are you going to go give that physical protection, if at all? There are some places where you, whatever you do, it's still going to be a challenge. So how are you going to solve those? And the third thing is, if you look at the smart objects, most of the things are manufactured in bulk or mass production, identical or almost nearly identical. So if one device gets compromised, mm, there is a huge a possibility that all of the devices gets compromised. So there can be a distributed denial of service. So how are you going to deal about that? And the next one is, you don't ever could have imagined, oh, this is the way my smart object could be deployed. Nobody even have thought about, oh, this device could be used in this way. The user will put it in a very crazy manner or some place where we never even thought of when you're designing that product. So how are we going to take care of those kind of misuse? So you have to be a little proactive in thinking all those. And now the devices, as I told you, the smart objects, when you put it in a forest fire or volcanic eruption, you cannot go there and check every time. So some devices are designed for 5 years and some things up to 40 years. So now the security mechanism which you're putting now, so it's going to be there for the next 5 years or 40 years. So how are you going to scale up that? So either the security algorithm should be very good and high enough to protect it for a long span, or it should have the deployment possibility that whenever there's an update, you should be able to push into that. And then mostly, if you look at the security protocols, the algorithms uses random numbers, and mostly the random numbers are generated using software. And now that becomes too costly onto an embedded device. So people should think of the random number generation using hardware and things like that when you do the design process. It explains about the privacy considerations when deploying smart objects. So RFC 6973 and the threat model in confidentiality document were written as guidance specifically for the engineering audience and are also applicable for the smart object context, which this all these slides is talking about. So the privacy considerations explained on RFC 6973 is adopted into the smart objects as well. So for those looking at privacy from a deployment point of view, the following additional guidelines are suggested, transparency, data collection, data access, and data security have to be properly handled. So when we say transparency, so what kind of, when you collect data from the user or the personal information, the person should be very clear as why his or her data has been collected and stored, and what is the purpose for which it will be used for. And the second one is data collection. So whenever you collect data about the user or the person involved who is using the service, so it should be very adequate, and you shouldn't take a lot of information which is not required for the context. So it should be adequate and relevant, and preferably it should be stored in the anonymous way, so that even if there is some compromise, something fatal doesn't happen. And the third thing is the data access. So there should be proper protocols and standardization procedures properly framed as who can access the personal data and at what conditions is he or she or the admin is allowed to access the data of the user. So those has to be defined very clearly. And the data security, proper standardized data security measures by using robust cryptographic techniques has to be deployed in order to prevent unhealthy access or alteration or loss of the smart object data, and also to avoid unintended data transfers or unauthorized access. So with this, the architectural consideration of smart objects is over. I would sincerely recommend that you go through the a document which is given in the reference link in the next slide, so which would give you even more broader idea of what exactly is the architectural insight of smart object is trying to tell us about. And it is a very very important model which will go along for a long way if you want to take IoT as your career. So IoT design methodologies is one among them. And then the IoT design models, communication APIs, and in the similar ground, this topic is also a important requirement if you want to take IoT as your career. So, which is your architectural smart objects and PP, smart object material which is given here. Thank you so much for patient listening. Have a good day. Thank you. Thank you for listening. This brings us to the end of Unit 4, and we'll join soon in Unit 5.